Ready, set, go. No, I'm kidding. That would suck, right? Let's not. Let's not. We don't want to do all this.
No.
There'd be 13 terms. That would take a long time, and we want to avoid that if we can. What I want to do is I want to try to figure out if I can use the binomial theorem, figure out that pattern, but only find one term. So let's say I want to find the term. I want to find the term. Find the term with an x to the 8th power. So I've got all my terms that are in there, right? I've got my first one's going to have probably x to the 12th. My next one's x to the 11th, x to the 10th, 9th, 8th, all the way down, right? I want to find out what the term is when it's just x to the 8th. So I don't want the whole entire expansion. I just want one specific term in that entire sequence, okay? Now, if you'll notice, the pattern for all these is the same. We have some kind of choose number, right? We have some kind of x that's being raised to a power, and then we have some kind of 2 that's being raised to a power. Right? We have our A and B, essentially, our first part and our second part. So we're going to have some kind of choose, like an upper and lower number. Then we're going to have these two. Now, if we can figure out what numbers go there, so that this gives me x to the 8th, that'll fill out the rest of it for me. So we just need to logically walk through what numbers are going to go where. So for example, first off, it's an x to the 8th, right? So what has to be the exponent on this guy? An 8, okay? So that one's kind of an obvious start. We're going to have an 8 right there. Another next obvious step is this. What's the numerator? What's the top number going to be right here in your choose thing? 12. It's got to be 12 because we have a 12th power for our binomial. Okay? So I have 12, choose something. I have x to the 8th to get x to the 8th, right? Now, what do I know about these two powers right here? Add to 12. So this has got to be to the 4th power, right? Now, what about this denominator? What about this lower number here in my choose now? It's got to be a 4. It has to match that number right there. Okay? So this is my general form for a one specific term in that entire sequence. I don't want to have to write them all out to find it. I just want to figure it out based on a little bit of logic. Okay? So put 12 choose 4 on your calculator. See what that gets you, right? So I'll do that real quick. 12 math over 3, 4. So I get 495. Because these powers always add to whatever the highest power is, which is 12 here. Okay? So they have to add that power. Okay? There's a lot of good talking going on right now. I know, that's awesome. Which one?
We're talking about the problem.
That's what I'm saying. That's what I'm saying. There's a lot of good talking going on right now. I like it. That doesn't happen too often. It's good.
People find it hard to differentiate your sarcasm.
I don't know if you guys were in that class. All right, so then raise 2 to the 4th, right? So 2 to the 4th, 16, right?
Yeah.
And so we go 16 multiplied by the 495. So multiply that by 16. So I get 70, that's not 79. 7920, x to the 8th. Okay, so that's the term that has the x to the 8th part in it. The coefficient for that term would be 7920. So they might ask you on this one, they might say, find the term that has an x to the 8th. They might say, find the coefficient of the x to the 8th term. Okay, so there's a bunch of different ways that they could pose these questions, but you're essentially trying to find one term and walk it through logic how those numbers are all going to work. Okay, but that would be the term of that. Now the other thing to think about is which term in the which term in the binomial expansion would this be? Well, your first term would be your x to the 12th, right? That would be your first term, right? Your second term would be your x to the 11th, right? And so you would think x to the 10th, x to the 9th, x to the 8th. So it's going to be your 5th term in that sequence right there, okay? Notice if you subtract there 12 minus 8, you get 4. You're always going to have one extra term on the inside if you were to do it that way. Okay, so that's actually the 5th term in that entire sequence right there. Let's do a couple more that are worded a little differently, but the idea is the exact same. Looking for one term, trying to come up with our pattern for this one. Okay, so let's go ahead and say I gave you, let's do this one. So how about 2x minus 3y, and then we'll raise that to the 10th power. And I'm going to say find the 5th term. Okay, so we're looking for the 5th term in that sequence right there. Now, just in general, I like to start out with what I know, right? Well, I know I'm going to have some kind of coefficient with my choose coefficient. I'm going to have a 2x raised to some power, and I'm going to have a negative 3y raised to some power. So that's kind of the given information that you start with. If you actually know even a little bit more, right, what's the top number have to be in your choose? 10. So that's got to be a 10. So that kind of is the basic beginnings. Okay, you can at least start there, I would think. Okay, you know that these guys have to add to 10, and then we're going to have this bottom number match whatever this number is right here. Now, if it's the 5th term in the sequence, the first term starts at 10 choose 0, right? That's what the first term is. So this is going to be 10 choose 4. The 5th term will have 10 choose 4. So now I've got the rest of them and I can figure it out. Now that's probably the weirdest part to figure out of all this, is that I have the 5th term Why the heck is that a 4? Well, think about it. Your first one is 10, choose 0. That's your first term. And then your second term is 10, choose 1. And then 10, choose 2, 10, choose 3, 10, choose 4. Because this guy, I know it's kind of weird, but if it starts at 0, it adds that extra number in there. Remember we had some sums that did that? It started at 0 and it was like, ooh, we had an extra term there? I know it's been a little while, but since I started at 0 for my counting principle, that's why I have to do that. Okay? So my fifth term is going to be 10, choose 4. Okay? So I'm going to have a 4 right there. Basically, just drop that one by 1 if you like. Okay? Now, this 4 right here, I can just put up here on the second next one. I know that these guys have to match. Okay? Those are always going to be the same. I know that these guys have to add to the power, so this is going to be the 6th power. Okay? Does that make sense? Not horrible, right? Okay, so that's the general idea of what you're going to be tackling tonight. So we simplify this. They might say find the coefficient of this term. They might say find the actual term. They might say expanded, the first 3 or 4 terms. It's all different. Okay, so 10 choose 4. Put that on your calculator. So 10, 210. You guys get 210 for that, I hope. Multiplied by 2 to the 6th power. Ooh, 64. And then x to the 6th, and then negative 3 to the 4th, of positive 81, so positive 81. Y to the 4th. And so we'll multiply those coefficients together. So we go 210 multiplied by 64 multiplied by 81, and I get, oh my goodness,
1,088,000.
That's a big number.
yeah, 1,088,640, x to the 6th, y. Okay? Not bad. It's just tacked on it yesterday. I didn't think we'd have time to get through all of this stuff yesterday, but that's the extra. Okay? All right, feeling pretty good about that?
Yes,
Not too bad?
Yay. Is this attached to our other homework?
This is attached to your other homework. Yep, $5.99. Well, I'm going to count it as a separate assignment, though.
Right.
So.
I know what the show is. Oh, this is so easy.